Hello and welcome everyone. I'm your host, Stefan Burns, geologist, geophysicist, space weatherman, cosmic bro, someone who's just interested in what's happening here energetically on the planet. So we look at earthquakes, volcanic activity, space weather, and planetary resonances and more. And well, looking at our sun right now, we see something that is not normal. Now, it's not like we've never seen this before, but this is quite rare. This is a gigantic, a gargantuan, a Goliath coronal hole. This is an area of the sun, the outermost part of the sun, the atmosphere of the sun, you could say, the corona. It's made up of very high temperature plasma. When it's not there, it shows up dark on our specific views that look at the corona. So this is our 211 angstrom view with the 193 angstrom filter on it. And we see this gigantic dark section showing that that part of the solar corona is devoid of plasma. Like, it's basically super low density, it's very low temperature, and as a result, we're actually looking a little bit deeper into the sun, this is, pretty rare. I mean, this is one of the biggest coronal holes, you could say, of the 21st century. We have solar cycles. The sun goes through a magnetic flip every 12 years or so. It's like 8 to 13 years is the range, meaning the magnetic field on the sun actually flips polarity. So this could be a northern polarity up here, a southern polarity, and then 12 years later, boom, they flipped. Right now, we're at the very end of solar maximum and the beginning of the descending phase. So solar maximum is when the magnetic field is the most chaotic. There is no clear polarity because it's in the middle of flipping. And then during the descending phase, the new polarity starts to become more and more established. And during solar minimum, you have a very clear polarity with the sun. You have a lot less activity with the sun. Solar flares are much less frequent. And you get these sort of coronal holes more often during the descending phase and during solar minimum. What's been very interesting about this solar maximum is that we've had these huge coronal holes on the sun. This just being one of a few that we've had this year, which are absolutely gargantuan. There are normal, sometimes we'll see them just this size like this, and this is a big coronal hole right there. Transequatorial, slicing right through the ecliptic. That means that it hits Earth with its high-speed stream. But the fact that this one then stretches to the south, even beyond that, is insane. So this is a gargantuan coronal hole. And the reason why I wrote, we have a problem is that there is a linkage between these sort of structures on the sun and how they structure the solar wind and geophysical energy rhythms here on Earth, namely earthquake activity, global seismic energy release, which already is not homogeneous and just like perfectly normal across time. It goes through these rhythms where things are really quiet, like kind of right now, we're actually in a little bit of a quiet period for the past few days. And then all of a sudden a big burst, which if you look at the longer time frame, 2025 is one of the strongest years for seismic activity ever on record. And well, we've had these gigantic coronal holes on the sun during solar maximum, and typically they become more prolific, more frequent, and bigger during the descending phase and during solar minimum. So if that trend is to continue, what we're seeing here could be a preview for some really, really insane coronal hole features on the sun, meaning that the sun could shed even more plasma by the time we get to solar minimum. And during solar minimum, they're typically up here in these polar regions like this. But right now, with it being solar maximum, the beginning of the descending phase, we're seeing them also cut through the transequatorial zone. So if it's in the polar regions, those high-speed streams that are emitted, the solar wind's always flowing out, they're not going to interact with the Earth because Earth is sitting here along the ecliptic plane. This thing does. So we have a big high-speed stream impact coming in very, very soon. This is a positive polarity coronal hole. I've been reporting on this now for a couple of videos. I mistakenly called it a negative polarity in one of my last videos, so apologies there. This is a positive polarity coronal hole, but this is one of the biggest that we've seen in the 21st century. I mean, maybe not like, it may be on the hand of 5, right? It also may be like in the top 2 dozen, something like that. I don't have an exact record. But we've been seeing some gargantuan coronal holes this year, and this is now the latest in this lineage. So this is quite interesting. Let us look right now at our geomagnetic activity, because we expect this high-speed stream to impact us and give us a geomagnetic storm in the near future. But we're already in one, folks. We just had a solar wind burst hit us. And as a result of that, we're in a G1 geomagnetic storm right now. So here is our magnetic field perturbations map for the surface of the globe. And we see that the magnetic field perturbations, or the swings in Earth's magnetic field strength, are highest in these high latitude regions. Here's our scale bar there. This is 0 nanotesla. It goes up to 400. Earth's magnetic field, for reference, goes from about 23,000 to 67,000 nanotesla. But during a geomagnetic storm, you can have swings of 1,000 nanotesla. If it's a really big storm, 2,000, 3,000. Like, that's a really big storm. But you can get those in select areas. But again, the total field strength, 23,000 to 67,000 nanotesla. So what we're seeing here are minor fluctuations. This is a minor geomagnetic storm, a G1. The scale rating goes from 1 to 5. 1 is minor, 2 is moderate, 3 is strong, 4 is severe, 5 is extreme. But we see that here we're getting it. And keep in mind, today is solstice. So happy solstice, everyone. Winter solstice for the northern hemisphere, summer solstice for all of you crazy folk down south. And as a result, Earth is really tilted right now. It's at its greatest tilt in reference to the sun. During equinox, that tilt axis is perpendicular to the sun. So everyone gets 12 hours of light because we're all rotating perfectly. But during solstice, one side will be tilted much more than the other, okay? And we have some interesting things to talk about there. Maybe people have talked about this before. Probably they have, but I just had a couple interesting thoughts about Antarctica that I want to share in this video because, well, today is winter solstice and it's perfectly applicable to today. So we're in a G1 geomagnetic storm. Let me show you the solar wind burst that we had, along with a couple other space weather things that are interesting. So we'll start with our solar wind burst that has triggered this G1 geostorm. This coronal hole, by the way, high-speed stream is expected to impact us in about 3 days. I mean, if we go forward here on the video, yeah, about less than 48 hours, we're going to start getting hit by that. Maybe even within 24 hours. We're getting pretty close to that geoeffective position for that trans-equatorial portion right there. So when that goes just a little bit further over, the solar wind kind of loops out like this and will connect to the Earth. And the thing I didn't really talk about is what happens is that this coronal hole emits a whole bunch of, effectively, it's a giant open magnetic field, because the reason why you have this coronal hole in the first place is that for some reason the magnetic field is split open on the sun such that it's not looping back in on itself. So it just emanates out into interplanetary space, and it goes quite deeply. And Earth at 1 astronomical unit is quite close to the sun. So we get connected to these magnetic fields that the sun emits. I mean, all the planets are enmeshed within the interplanetary magnetic field, but during a coronal hole high-speed stream impact, we connect directly to it. And the bigger the hole, the more strongly we're embedded in that unique magnetic field that is, coming off of the biggest thing in our solar system, 99.86% of the mass. Right? Without the sun, we'd be doomed, basically. I mean, yeah, none of us are going to make it if we don't have the sun. So unless you're like a deep sea hydrothermal vent worm, and don't sign me up for that. If I beam up and then they're like, do you want to go back to Earth as a deep sea worm? I'm like, no, thank you. I'll go somewhere else. So we have a lot to give the sun thanks for. And it has a big influence over us energetically. We can't just dismiss that. I think we just take it for granted. I really think that most people just simply take it for granted. And they, as a result of that, they just simply can't even comprehend the power of the sun. I think myself and everyone here watching this live right now, though we watch the sun all the time, we're knowledgeable about it, educated, learning about it, I think all of us take the sun, actually underestimate the true power of the sun because we simply don't know what we don't know. So let's look at our solar wind burst right here. that triggered a G1 storm. Some people saw some aurora from this. And if you watch my cursor there, we see that we had some geomagnetic activity going up to G1 minus levels right here on the 17th of December. And then things went quiet around the 19th. That was the closest approach of 3i Atlas. That's also when we saw that unusual Schumann burst. That was right around here. It was at about 3 a.m. Universal Time. It was 2:40 a.m. I believe specifically, or no, it was 3:20. Was it 3:20? Anyways, it was like 3 a.m. Universal Time on the 19th, an unusual Schumann burst. We see that our solar wind parameters were normal at this time. Now we see though we've been ramping up. There's our 4.67. There's a 5. So that's a G1 storm. It was triggered by this magnetic field up there. So we see the interplanetary magnetic field went from low values of 3 to 5, which is normal, all the way up to 14, so nearly triple. And also this red line shows the southward component that went negative. So just a bit of a burst of activity. It's kind of settled down now, though we're still nearly double in strength. You see that the black number there, 9, that's 9 nanotesla. Normal field strength again is about 5. And solar wind velocity is up to 682 kilometers per second right there. We see that right there. See the purple? 682 kilometers per second. That's quite fast. So we've been in some high speed, high velocity solar wind for a while now, actually. It's been kind of elevated. If you check out this right here. So we see how these things can create geostorms. And there's also some other influences here beyond this, but we see that recently we've kind of been elevated. We haven't like had this long cool off period like we did here. We've been up there tapping 600, 700 kilometers per second now for a while. And we have this other coronal hole that's much bigger than the last one coming in very, very soon. And also I think it's interesting to note that this thing looks like E.T. from E.T. the Extraterrestrial, the movie. So there's the head, there's the neck, and it just looks just like it in my opinion. It's pretty. Is the sun telling us, like giving us a sign? Is it cluing us in as to the alien invasion future? Well, that's for you to decide. I hope that's not in the cards. So a lot of people seem to think it is. But regardless, a lot of people think a lot of things. So here we have our most recent coronagraph imagery for the sun. And we're looking at this because this shows us a couple interesting things happening right now. You see these two bright objects right now. This one right there is a little harder to make out, but you see that's not moving the same rate as the background stars, right? We see these stars are all moving like this, and this one's kind of resisting that flow, you could say. Whereas this bright object is moving forward. This is Venus, this is Mars. We're looking at the sun here. They put this disk over it. Specifically, it's outlined in white there. That's the size representation for the sun. But this allows us to see the solar wind outflows from the sun. We see nothing has occurred over the past 24 hours. So no solar storm launches, no filaments. The sun over the past 24 hours has been exceptionally quiet. But we do see Venus and Mars. They are going to meet up in a conjunction together as viewed from Earth. At the same time, they also go cazimi with the sun, which is a superior conjunction for both of them this time, though Venus can also do inferior conjunctions. Superior conjunction means that they're on the outside, the far side of the sun. So you have Venus on the other side of the sun, which is why it appears so bright, and Mars is also on the other side of the sun. It always will be as viewed from Earth. Well, not necessarily, but if it's doing a solar conjunction, it will be. You'll either have a solar conjunction, a superior conjunction, or an opposition. Those are the two. If Mars and Earth are in a line, and then the sun is the other part of that, that's an opposition. We have that coming up at Jupiter actually on January 10th. We've been talking about the very interesting planetary geometry that we have coming up very, very soon, like this January, just like 2 weeks away, less than that. And we'll continue to talk about that. We'll probably touch on that a bit more later in this video. But this is a powerful planetary signature. And what we sometimes see is that when they go conjunct, that seems to trigger like a new phase of solar activity and sunspot growth. Can't say that definitively, but we have seen with prior synodic cycles like that activity. Because that's Mars, Venus, solar double conjunction with the sun as well is a 6.6 or 6.7 year cycle that occurs. Every frequency, every 2,338 days, we get something like that. Here we see what's happening on the far side of the sun. This is pretty wild. We got some big sunspots, folks, on the far side. So if you look at my cursor here, this is the Earth-facing side. So we see a magnetogram for the Earth-facing side. Here's the far side of the sun. And these dark regions are big sunspots. So we are getting some sunspots rotating in right now. But look at this guy. This is the big sunspot group that left. It has not diminished in size. We're actually even seeing it from the reconnaissance orbiter on Mars, which pulls up its camera, its mass cam, and takes a snapshot of the sun every day. Maybe it doesn't do that when it's like super dusty or something. But you can even see sunspots with that mass camera in those photos from Mars. And right now Mars, because I just showed you, it's on the other side of the sun, is giving us perfect visibility of that. Well, we also see the helioseismic, big sunspot groups. There's actually a lot of sunspots right now on the far side of the sun. And I'm not sure if that's going to be up on Space Weather News or not. Let's check it out. I saw someone else post the graphics. I wonder if they went ahead and posted it here too. Doesn't look like it, but I can just go back one day too as well. No. Anyways, we also have an interesting update about 3i Atlas, and I want to clear up some confusion here. So this is a really well-known photographer, space and other photographer, Andrew McCarthy, and he took a great photo of 3i Atlas recently. I mean, this guy's got really good stuff. So he's taking some good photos. Notice how it's starting to go from green to gold. We talked about that and we were kind of waiting better imagery, right? Now we really clearly see this golden color associated with dust, and the coma is still partly green because it still contains some of these compounds that burn green. But we're seeing this transition from green to gold as it moves from Virgo to Leo, the constellations, which is pretty interesting. And here is zoomed out view. And so we see the two tails. This is sunward facing, and then this is anti-sunward facing. It's bizarre because of how opposite they are and how this is really staying sunward facing for so long. It's really quite odd. But he brings up a good point. And this is something that, I'll do my clarification afterwards, okay? Why didn't NASA release high resolution photos of the comet? The photos that Hubble took the photos that Hubble took fit within the red square, and the photos that James Webb Space Telescope took were even more zoomed in. Remember that they're focusing really far out into the deep cosmos. So they're looking at very tiny things. They're not wide angle, wide field. They're very narrow. So they can't really expand out and get a wider image unless they create like a mosaic, which they could take a whole bunch of high resolution images and then tile a mosaic and create that composite together. But amateur telescopes in some aspects, because they're more wide view, take better shots of comets. So this is where Hubble's image would be right here. And that makes sense because Hubble showed us really clearly the inner coma. And then he goes on saying, if you want pretty pictures of comet tail, you don't put multi-billion-dollar space telescopes on it. It's better for amateurs to cover that. And I'll say that I do think there's a little bit of shenanigans and weirdness happening with NASA in general, like across their history. There's a lot of odd things, okay? But I also am not someone that just immediately thinks everything is conspiracy, all right? So this is a great photo because it shows us a transition from green to gold, and it also provides a bit of context as to that zoom in and what we're actually seeing with Hubble. And so some of those images, they don't look all that spectacular, but it's actually a much closer view on some of these things. And if you were to zoom this in, let's say to cover the same area, the resolution would be even lower than like the Hubble image. So keep that in mind. Also, there are like a lot of people that are doing exactly that. They don't have that super high depth imagery from, let's say, Hubble. So they're using their normal telescope and then zooming in digitally, creating a ton of artifacts. And then at the same time, if they're on Earth, right, because Hubble's up in space, if they're on Earth, they're getting all this atmospheric noise, because when light hits the atmosphere, it creates it scintillates and it creates noise and distortions that take time to filter out, and you can't do it completely. And so then you get that artifact as well, and things can really get weird looking. And that's basically what's been happening for the past few months with 3i Atlas, is that a bunch of people have been doing that, digitally punching in, and then all these artifacts have been popping up, and then claiming those artifacts are 5 new craft that are hovering around it, or some ring structure that's doing this, and they're going cross-eyed. And at the same time, then some people take those super punched in photos, which have terrible resolution, and giving them to an AI to up-res and to enhance, and then it takes artistic liberties and gives it all this crazy stuff and turns it into a some spiral thing, and then everyone's minds explodes. So that's what's been happening. Okay, it's not like there's no anomalies with 3i Atlas. Like, this is kind of weird. Right? The fact that the tails, one is going straight to the sun, the other exactly opposite, this is pretty bizarre. It's not behaving in many ways like normal solar system comets, because this is an interstellar object. It's an ISO. But there's also just a lot of stuff out there which isn't proper and accurate. So what I kind of wrote about this is that, you can look at some of these things and be like, oh, it's so mysterious and interesting. And that's, it's good to be curious and to be interested in things. But if these things are fundamentally not true, you're getting stuck on a fake mystery. Whereas if you learn and educate yourself, then the real mysteries of the universe open themselves up to you. So that would be just kind of my thoughts and recommendations on that. Put aside the cheap cookies and go actually and get the fancy dessert at the nice restaurant. Treat yourself. Treat yourself. Now, something else interesting that has occurred, we had that Schumann burst back on the 19th, right? We have some data from HeartMath Institute, and I was looking through their spectrograms for California here, and we observed some spectral resonance structures, which are quite rare. So if you look at the spectrogram here, this is the magnetic field, and I can just kind of zoom this over. See these lines right there? Those are spectral resonance structures. And these are very unique frequencies of energy that will exist during quiet geomagnetic conditions. So you don't get them typically during a geomagnetic storm, but when things are quiet, they'll all of a sudden pop up. And they exist at frequencies lower than the foundational mode of the Schumann resonance. Also, though, they can go all the way up to 30 hertz. So that is overlapping with our biological rhythms and our brain waves, just like Schumann resonances. And they can show up and resonate with higher energy, just like Schumann resonances, sometimes under unique conditions. So here, this spectrogram shows the magnetic field. You don't get them with the vertical electric field too often. Typically, it's a magnetic field resonance. But we see them coming out of, this is from California. So these spectral resonance structures are even lower frequency. And this is quite bizarre. Now, but we do see them typically every year around this time. This is right here. What date was that? That's for the 15th of December. And this is for the 14th of December. We see them also down here, right there. There's some more spectral resonance structures. There's a little bit of noise and bleed right there as well. But we do see them as well there on the 14th. And this is for California. They also have, for example, like Lithuania here, GCI 003. And we don't see those spectral resonance structures for Lithuania. And we don't see them down here for, was 5? Is 5 New that is New Zealand. We don't see them down here for New Zealand. So they can be localized to certain places where that part of the magnetic field that's connected to, let's say, California, because every location on the globe has a magnetic funnel that kind of extends out to space, you could say. You call them magnetic field lines, but it's just the flow of energy down the magnetic field. Every location on the globe has a connection to space. Other than like basically right at the equator where it actually loops back to the other side of the Earth, but regardless, to keep it simple. So this is going all the way out to space. So if there's some special resonance phenomenon that's occurring in our local space environment in the magnetosphere, then that can bleed down and create these spectral resonance structures in that area that's connected. And also the reciprocal point too, which for California, I'm not sure what it is. If we had a probe there, we'd probably see these as well because they'd be linked together. But I don't believe they have a probe exactly. I mean, they only have 6 stations and 3 of them are offline. But these spectral resonance structures are very, very interesting. Now, I also wanted to talk about solstice really quick. Winter solstice light. Yeah, maybe this winter solstice light will give us what we want. Because kind of need a graphic here to show you this, and this one does it. Let's look at this graphic here, okay? So happy solstice, everybody. Hope you're having a great one. And today, this is effectively the orientation of the Earth to the sun. So the sun would be exactly that direction, right? We see this is the sunlit half of the Earth. This half is now in darkness. I'm now in darkness with where I am, with where I live. Some of you may be enjoying a lot of light if you're in the southern hemisphere. So in the Arctic Circle, they have pure night right now. No sun. They may get a little bit of sun on the horizon when they rotate towards that angle right there, if they are right there. But if you're right in the North Pole, you're not getting anything, okay? And then if you are in the northern hemisphere, you're getting less light than you are normally, okay? But southern hemisphere is the opposite. Now, most of the landmass on Earth is concentrated in the northern hemisphere. So we have this ocean and land imbalance. And so that affects, as a result, the climate and perhaps many other geophysical forces and systems when we go through our orbit from solstice to equinox to solstice to equinox. Because light is a tremendous amount of energy. 1,360 watts per square meter or so is hitting Earth's surface at any given moment. Goes up a little bit. This is total solar radiance. It goes up a little bit during solar maximum to about 1,364, and during solar minimum it's usually like 1,360. That's kind of the zone. Well, that's heating up the Earth, and different light radiation absorbs in different parts of the Earth energy system. Like the very high frequency light absorbs into the ionosphere, but a lot of that light goes straight down to the surface, as obviously, when you're out and about, you can see, right? What's interesting about winter solstice is that Antarctica is a big continent, right? It's a big continent, and it's completely covered with ice and snow. So it has a very high albedo. So it reflects a lot of light. So today, right now, we are having Antarctica exert its greatest albedo effect upon the planet. Because during summer solstice, summer for the northern hemisphere, Antarctica is going to be in darkness for 6 months. But right now, it's exerting its greatest albedo effect, reflecting a lot of that sunlight back out to space. Here's something interesting to think about Antarctica. It's actually basically the largest desert on the planet. It gets very, very, very low snowfall. These ice sheets have built up over like millennia, all right? I mean, we have ice cores that go back 1 million plus years. So they've been building up for a very, very, very long time. Of course, there's going to be some variability in the thickness of the ice and the extent of the sea ice and things of this nature. But in general, Antarctica has had ice on it, as far as we know, for hundreds of thousands of years and beyond. And if this wasn't covered in ice, we wouldn't have that albedo effect. It would be greatly reduced. Or if this was just open ocean, it would also then be greatly reduced. That's kind of one of the fears of there being less sea ice around Antarctica, is it means, the ocean has very low albedo. It absorbs radiation very easily. Most of the heat gets absorbed into the ocean, and then it takes a long time to radiate out. So that really heats the Earth up. But let's go back to Antarctica. It is one of the world's largest deserts, if not the largest, and also has some of the lowest snowfall rates or rain rates basically across the board. So it took a long time to build those ice sheets. We also have one of the largest volcanic arcs under Antarctica, under the ice sheets. And if they were to start getting very, very active, you can imagine that would lubricate these ice sheets and they would just totally flood into the ocean. And then think about how if all of a sudden Antarctica no longer had ice, how quickly that would start to change Earth's climate, as every winter solstice or summer solstice for them, it was just baking and absorbing energy. So a lot of our heat budget, our climate in many ways being stabilized by the albedo effect of Antarctica. It's not insignificant. If that was to change, that would be quite significant. And we have this huge volcanic system underneath, which could feasibly, if it got really active, totally destabilize and shoot these ice sheets off into the ocean, melt them pretty dramatically, exposing the bare surface of Antarctica, changing everything really quickly. So we have to give thanks to the system that exists right now, because even though things may not seem stable, they could be a lot crazier. Right? They could be a lot crazier. There's a lot more runway for this to fall in terms of the global warming thing, because the Earth is getting warmer. The question is it going to swing back to a global cooling or even a glacial cycle soon? A climate ice age? It's possible. We're in an interglacial right now. At some point, I'm sure in the future, we're going to be in a glacial, unless we entered into a completely new regime for millions of years, which is possible with what we've been doing anthropogenically. But there's a lot of runway yet for global warming too. So it's not like just because we're in an interglacial and there has been a regular rhythm of us being interglacials and then going back to ice ages, doesn't mean that we are destined to go back. We may not. We could become a water world pretty quickly, especially if certain volcanoes awaken. And that's influenced by things like solar activity, right? The energy output of the sun influences the geophysical systems here on Earth, the energy budget of the Earth, because a lot of this energy deeply penetrates into the Earth and influences the energetics of not only the mantle, but also the outer core, the inner core. So really quite interesting stuff there. Just wanted to share that. And we'll finish by looking at our recent solar flares. Not too many, but we did have a 1.3 M-class flare today. And here it is. This is the past 2 days right here, past 48 hours of solar flare activity, Earth facing. Our 131 angstrom view, you'll see this 1.3 flare from, it's either this one or that one, very, very soon. So give that a watch. It should come up in about 5 seconds or so. But we see these sunspots that are rotating in. Oh, there it is. That little guy right there. Boom. And still showing some activity. So that's interesting. So we do have a new little flare player, little Billy, little Timmy, Tiny Tim. Tiny Tim is showing that it can do a little something. But it's nothing big yet. This sunspot group there, right there, though, looks quite a bit more significant. And we do see some good activity off of that. If you watch that, it's kind of crackling, and that's typically a sign of incoming activity. So certainly over the next 2, 3, 4 weeks, we got some activity headed our way. But right now, things are pretty quiet in the grand scheme. And just kind of wrapping it all up, our plasma environment of the sun is influencing the Earth geophysical system, because we've discussed ad nauseum here on the channel the connection between coronal holes and earthquakes. Correlation, causal, you make up your mind, but we've seen time and time again the biggest earthquakes occur after the high-speed stream impact of these giant coronal holes, and the biggest earthquakes on record occurred when there were gigantic coronal holes like this on the sun. I'm talking gargantuan. So that is just undeniable record. For the records that we have, you can look it up, and that's what you will find. If you really doubt me, just do it. Just do it. Just like do it, and you will see that that's the data. So there's something to it. And this is a gigantic coronal hole, and these seem to load the Earth with more energy internally. We saw that historic eruption at Haile Gubi in Ethiopia. That's part of the African superplume, one of the biggest mantle upwellings and plume systems on Earth. Guess what? The Antarctic plume system is also one of the largest on Earth. So all these systems are interconnected, and it's you know, I don't really have too much hard data for this, but it's my intuition that we are seeing kind of an increased amount of heat flux hitting Earth's mantle, which is then translating to these volcanic eruptions that we've been witnessing, and also translating to the earthquake activity. Because again, 2025 has been one of the biggest years of seismic activity ever on record. The 5 years of magnitude 9+ earthquakes have had more total seismic energy release because they're magnitude 9+ earthquakes. 1906 was a tremendous year for seismic energy, and that year barely had more than us as a result. We, of course, had a magnitude 8.8 megaquake this year, making it the majority of the seismic energy release, but we had tons of magnitude 7s, and overall, it's been a big year for seismic activity. So that's undeniable as well. So that is the Space Weather and Earth Geophysics report for you all. I'm now going to take some questions. So if you have some questions, you can ask them in the chat. You can just keep them on topic, and I'll do my best to answer them. I will also answer any questions that pop up as super chats. So if you want your question to get answered, then make sure you do a super chat. But for right now, I will take some from the general audience to start, to make it fair for everybody. Give everyone a shot, though I see that there's quite a lot of you here in the live stream. And thank you all for being here. Happy solstice. I hope you're having a great time. Happy Sunday. How long do we have? Ask Akima. Well, it depends really on you. Are you going to get lucky tomorrow and live another day? I don't see anything on the horizon in terms of like some doomsday scenario. I know a lot of people, for some reason, they A, want that, or B, they think it's coming because someone told them it's coming. But I don't see anything immediately that is indicative of that. Though Earth undoubtedly has a cataclysmic past. So it's like, if you want to understand the Earth and what's happened and the geology and more in the systems that exist right now, like plate tectonics, you have to understand these cataclysm cycles. You have to understand these sort of asteroid and comet impacts that Earth has had over time. If you don't, then you're not going to understand what's happening. But just because you study something and you educate maybe a bit on it does not mean that you think that the doomsday is coming. They're pretty rare and infrequent, thankfully. So it's as much time as you want. If you want to live a long time, then eat healthy, walk every day, treat others with respect, and treat yourself with respect, and hopefully you can make it a long time. And Mimer is asking, what type of telescopes am I looking at? This is from the last live stream where I mentioned I was thinking about getting a telescope. I don't know, but it's going to be a big honking one. If I'm getting a telescope, I'm not going to get a tiny one. So I haven't started the telescope search yet. I'm still waiting to hear back on some other stuff. But whatever it is, it's going to be good. Okay, so you don't have to worry about that. And Martin's asking how much time before the lights go out. Well, if you're in San Francisco, they went out yesterday for like 150,000 people. And I actually messaged my friend, and she's like, it's fine with where I am. But a huge power outage hit San Francisco. Now, the only thing that would trigger like a global lights out would be, I don't even think a Carrington event could do it. If we're talking global, I don't think a Carrington event would do it at this point. I think we're talking super flare. which can be 10 times bigger than a Carrington event. So, and even then, it's not guaranteed. Like our technology might actually be fine, but certainly a Carrington event would definitely have a technological impact. But is it going to be like a global nights out for everybody? Probably not. There's probably going to be plenty of places that are fine, but it's also going to be like a disaster thing. Like if the United States, for example, has this big blackout from a really powerful solar flare and solar storm combo, right? Let's say it's equivalent to the Carrington event. And we have enough transformers go out that the grid goes down in large swaths of the US. Well, if we got more transformers and the crews go out quickly, hopefully we can repair it pretty quick. But if we send all our transformers off to some other country, then yeah, it's like we could be out of power for a while. So be prepared, be aware, be aware, be prepared. These are all good things to do. But in terms of like some imminent super flare, like we don't have any evidence of that. We know that these sort of flares exist on sun-like stars, and there's evidence here on Earth, radioisotope evidence, that we've had some big impacts like that in the past. But in terms of being able to predict that going forward is something that is, I don't think, really possible in a concrete sense. So yeah. And Pikachu is asking, wondering if this is normal. Has it happened before? Yeah. So normal in the sense that we have seen these sort of coronal holes before in general of this size and specifically for this year. But in general, coronal holes this large are not normal. This is a gigantic coronal hole. So it's not often that they show up this big. So the fact that it's infrequent makes it not normal. So this is quite abnormal, but 2025 in particular has been abnormal because we've had a few of these now. So it's almost become normal, but it's not. And these coronal holes, they get bigger during, typically more frequent and bigger during the descending phase and during solar minimum. And we've been having them during solar maximum. We're going to descending phase now. So the fact that we're already having them of this size and we're about to start hitting that phase of the solar cycle where they really proliferate and get bigger is like, whoa, what is happening? Because this is showing a huge drop in the plasma density for the outermost part of the sun. So how does that change the solar dynamics? That's a good question. We don't know everything, right? I think some people, like some like NASA, for example, right? I'm not 100% on board with them because I think there's a lot of like, oh, we know everything. We don't know everything. So like gigantic coronal holes on the sun continuously, how does that affect the overall system? The magnetic field is open here. It's just emitting out into space. How does that affect the Earth, the other planets? These are all good questions. And Nancy with the good question is, what is causing the sun to lose so much plasma? That would be the magnetic field. Because that magnetic field extends out into space, it shuttles the plasma that's normally there and accelerates it into that high-speed stream. And because it goes really fast, now it's a lower density. So it really is quite simply the plasma shuttling this out, or the magnetic field shuttling this plasma out that is causing this. This I 100% agree with. Yeah, absolutely. So that's kind of one of the bigger problems here. If we're really discussing problems here. And see, I didn't realize that my screen was cropped because someone changed the default settings, and I thought we were just running with the normal defaults. So now we're zoomed in, guys. See, there's so many settings to always choose with live streams and such. Either way, we're good now. Sorry about that. And Secret Owl is asking, when will the stream hit us? Within the next 48 hours. So in the next 48 hours, that coronal hole high-speed stream should hit us probably in about 20, I'm thinking probably about like 30 hours or so, but we'll find out soon. And we have some super thanks questions that have come in. From W2F, no just no. Thank you, bro. They're saying, been watching a while with YouTube, but somehow the algorithm unsubscribed him, and they like my analysis. Stay stellar. You stay stellar too. Thank you so much. And Underwater Panther with the super thanks. Thank you so much. Happiest of holidays. Thank you for the Astro Embodiment attunements. Yes, of course. You're welcome. CW Davis, thank you for the super thanks. Anyone feel or experience Dance Antony after last week's 3-Eye Atlas meditation on? I'm not sure what you're saying. See, it's important just in general to make sure you type your sentence out nicely, though maybe you're not a default English speaker. I don't know. But dance grooves, I don't know. I'm sorry, but thank you for the super thanks. I'm sorry, I can't decipher that. Can you explain why there's holes on the sun? Yes, magnetic field. So we explained that a little bit earlier. Thank you, Monica, for the super thanks. And from Australia, do you have a book yet? I have a gut health book, the Holistic Gut Health Guide. That is available on earthevolution.com/store. I have worked on and off on a book with, on Earth geophysics and space weather and some of my other thoughts and ideas as well for years now. But I keep learning so much that I don't want to release a book that's out of date the moment I publish it. So I'm getting to the point now where I feel like I could publish a book and have it sit on a shelf for a while and be really good info. And I was also talking to someone earlier, and sometimes you don't realize kind of like where you are and where others are, and like publishing that book would be really good info for a lot of people learning about this at the beginning. So something will be coming out within a few years, I'm sure, because a lot of legwork has been done for it already, but it's not out yet. Will this coronal hole affect air travel? It shouldn't. It can cause geomagnetic storming, but it seems the bigger issue with planes is less geomagnetic storms and more really intense bursts of high energy radiation from the sun, like from a solar flare. Remember, Airbus grounded 6,000 plus planes because of a solar activity issue. So it seems that it's more likely actually from cosmic rays, but regardless, there are real world effects from solar activity. So it shouldn't affect air travel. I wouldn't be worried about it. It's more the big solar flares. I'm like, if there's a whole bunch of like X flares popping off and I have a flight coming up and I can like cancel it or change it, I personally do. Because it also makes weather more volatile. And so like recently I had to fly like through Chicago, and then these X flares are going and Chicago is already getting like a crazy blizzard to go through. I was like, yeah, I'm not doing that. And it was nuts, and it was a good reason. It was good that I changed it, because then I saw the aurora and everything. That was back in November. Starshine, why is the sun losing plasma? Will that affect us? I did answer why it's losing the plasma earlier. It's because it's being shuttled out by that magnetic field. Will that affect us? Yeah, these high-speed streams hit Earth directly and create geomagnetic storms. There's also the connection to earthquakes, which you could research into. Some people say that there's no connection at all. And, well, if you look at the data, there basically is. So I don't know why they keep saying that, because if you look at the data, like you actually read the research papers and look at the data yourself, you will see the connection. So complacency is an issue in society as well. But yeah, so there are like these downstream geophysical effects that can occur as a result of this. And Kalenas is asking, what do you know about solar maximum affecting our weather patterns on Earth? Well, in general, weather becomes more intense, so more volatile. We see, for example, actually there's a really good connection between coronal holes and tornadoes and also cyclones. So what we see is that coronal hole high-speed stream impacts increase vorticity. And specifically during certain times of the year, that is a significant effect. And vorticity is one of the main things that you need for tornadoes or cyclones, otherwise known as typhoons or hurricanes. So 2025 was a record year for tornadoes, and we had these big coronal holes, one of them similar in size, back in March, late March, hitting the earth right around that time. And then we had a huge tornado outbreak early April, right afterwards. Guess what also happened? March 29th, magnitude 7.7 earthquake struck Myanmar, Burma, Thailand. That zone, that whole area got shook with a huge earthquake. Guess what was also happening then? We had a inferior conjunction of Venus and Mercury. So Mercury and Venus were exactly in front of the Earth, in between the Earth and the Sun. This time we have Venus and Mars on the far side of the Sun, about to do a conjunction, the first time they've done it in 6.6 years. So very similar what's happening right now to what happened back in March. And the coronal hole in March was also transequatorial, looks similar to this. I think this may be the same one. It's also positive polarity, which makes me think that, because this is taking on a shape very similar to that coronal hole, which has had, if this is the same one, it's like 18 rotations now or something like that. It takes 28 days to rotate around in general around the sun. So yeah, they can affect weather patterns. There's research out there, you can read it. And the people that say there isn't a connection, I think they just haven't read the research. So I don't know, but there's like good research out there showing the connection between coronal hole high-speed stream impacts and tornadoes and cyclones. It's really interesting. And thank you, Mary, for the super thanks. Happy holidays to you as well. Do you have a Discord? I do not have a Discord. If so, why not? I just don't really. There's always another platform to spin up, and I've created a couple chat rooms before, and they always just devolve into chaos. So I'm not so interested in creating a Discord. Just another thing to manage for me. But I like the idea. What do you think would need to happen for NASA to eat some humble pie? I'm not sure it's going to happen. Because it's like an organization. So if this has kind of been built into the organization now, it's just going to require new blood to come in that is just kind of resistant to that indoctrination, and then the old people just to go and leave. But echo chambers exist, and it's rare to find someone who can admit that they've been wrong. I've done it many times on the channel, as longtime viewers will know. I've made mistakes, and when I do, I do my best to call them out and let you guys know. So because it's just the right thing to do. If we're interested in what is actually happening, then that is the only course of action, because that's the primary objective. Who cares what I said earlier? I'm a new person now, or you're a new person now for learning the truth. You just move forward. So, but when it comes to organizations and they're seen as an authority, if they're wishy-washy, then that can create problems, I guess. I don't know. I was talking to a friend about this earlier today, about sometimes these connections are so obvious that you wonder, and then people deny it, and you're like, what the heck are you talking about? So let me show you this, because this is really a good example of this. We've been having some eruptions at Kilauea volcano in Hawaii. A lot of eruptive episodes now. We're actually about to have a new one very, very soon. Let me show you the data. And here is the data. Just need to shift that back over for you guys. Okay, so here's our data, and we see we're looking at the electronic tilt for Kilauea Summit, and it increases as the caldera fills up with magma, and then it deflates when it goes down. So I'm going to turn myself off. Look here. We have our past month of data right here. This is episode 38, I believe, and this is episode 37. We had this deflation event where you have this big eruptive episode, okay, and look here. This is how much the caldera is deflated, or the magma chamber effectively is deflated each time, right? So fairly regular rhythm, right? You can see that across 3 months here, and even further back, you can see that going quite a ways back, okay? This spike right there, see that right there? That is an earthquake that occurred the moment that eruption finished. So people in Hawaii, in Volcanoes National Park, in that area, there was I think it was a magnitude 4.6. It was like 4.2, 4.4, 4.6, something like that. significant earthquake. You could feel that. It hit the moment this finished, within like 5-10 minutes. And USGS came out and said, oh, they're not related. Like they're definitely such a coincidence. Meanwhile, the earthquake occurred in Volcanoes National Park right next to Kilauea the moment the discharge finished. Okay? Not connected. Well, guess what? Look what happened afterwards. We had this fill up right there, and then we had the biggest eruptive episode yet in this whole sequence going back to December of last year. It's been a year now. It completely broke through this trend here, right? A massive discharge event, so big that it actually knocked out one of their cameras. Because there's 3 different events that were going, and it shot out so far laterally, and it still reached a height of like 1,000 feet, but it went so far laterally, it actually knocked out one of their cameras. And that went viral for, that footage went viral, which is interesting. But here you have this event there, a short one. Then you have an earthquake right in the area, which is going to create fractures and loosen up everything. And then you have the biggest discharge, highest volume event afterwards. And they're like, there's no relation. That's exactly what happened. I mean, you gotta look at sometimes you have to learn how to read the data yourself or find someone you trust that is looking at this, because there's like other motives that some people have. And my only motive really is to put a roof over my head, to make sure I can feed myself, and to understand what is happening with the earth, right? I really want to understand as best as possible the earth-sun-cosmos connection. Besides that, I'm a happy guy. I don't have any political motivations or whatever. So it's kind of a long one, but that is kind of my thoughts on your question, Margarita, or Android. And Margarita Diaz, thank you for the super thanks. Will the sun start radiating less heat? It shouldn't affect the heat of the sun, but if the coronal holes get big enough, I don't know. But it shouldn't. I'll look into that more. That'd be an interesting thing to look into, whether coronal hole activity influences total solar radiance. I don't have an answer for you, so I'll look into that. Thank you, Margarita. And can you recommend a certain hand crank radio? I can't, but I'm sure you can find a bunch on like Amazon or something. Though, we have to start moving away from like supporting Amazon. They have this like algorithmic pricing, and they're kind of scummy. So maybe go to like a local electronic store, see if they have something. I don't know, do some research online, but I'm sure you'll find something good. I don't have a recommendation for you. Thank you, though. And Ami is asking, I live in Tucson, Arizona. Last year we only had snow once, so there was no water in the lower canyons in spring. What's going on? What's going on? We are losing our water. Well, there's been a lot of, I don't know about Tucson, Arizona, but I imagine this is the case there because you guys get very low rainfall. They are pumping the aquifers dry, girl. I'm sorry, like everywhere, like in the United States, California, the Southwest. There's really deep water aquifers, because we think about it. Before us, like us, as the Native Americans, they weren't drilling wells. They knew how to live off the land. Okay. Whereas we're like, hey, look at this desert that gets extremely hot. Let's build a city here of like 1 million people. Oh, we have these aquifers which have been built up over thousands of years that take a long time to replenish, but they have huge amounts of water in them. Let's pump them dry. So I can't say definitively whether that's the case, but yeah, Tucson, Arizona, and in 150 years, now we have these big cities and we're just pulling water. That's what's happening. So no surprise to me. And so what happens is the water table goes down. And so if you have a spring that's fed, let's say from 200 feet down, and the water table goes from 100 to 300, that spring is going to dry up. So we're having these sort of problems all across Western United States. It's a serious problem. And then you also introduce fracking, which is disrupting water tables and causing a lot of problems in the United States and elsewhere around the world, Europe and more. And yeah, like we're I don't want to get started. It upsets me what we do to the earth. in our ignorance. Happy solstice. Are you going to lead us on a cosmic healing journey this evening? I may do that. There's a lot of questions to get through, but may do a quick, like 10-minute cosmic connection. So thank you, Linda. Thank you, Jerry and James Spitman. Thank you so much. Really appreciate that. Mercy9292 is asking, 3D matrix is coming down due to elevated consciousness. 3i Atlas came to support, sending us codes and interacting with the sun. Possibly the sun has enough force to hold the 3D grid, but it has now broken. Yeah, you're in a interesting you're in an interesting rabbit hole, I will say, and I encourage you to keep following it. Maybe it's a little bit beyond this video, but I definitely 100% think that our consciousness here on the planet is connected to the sun, the planets, the rhythms of the cosmos, and then also there's like these yuga cycles, the great year cycles. There are these cycles of consciousness that we have historical records of. So it seems that we're in this ascending phase of consciousness. So yeah, I mean, there's certainly some like heavy forces weighing down on the planet, and a lot of people just not really awake and aware of what's really at stake. So yeah, I hope the 3D grid gets lifted, we go 5D, but we'll see. We will see. How long to replace the plasma? It's a good question, James. These coronal holes typically will close up after a few rotations, but the ones that we've been having have been persisting for 5, 10, 15 rotations. So it's a little bizarre. The problem is we don't have that much data on this. Like Solar Dynamics Observatory, it's not 100 years of data that we have. We have some photos of coronal holes on the sun from 1973 from Skylab, which are the first good images that we have of the sun, kind of like this, but the record isn't continuous. So it's hard to say what is normal, what's not normal in that regard. But we know that this size right here is abnormal compared to normal, though we do see them occasionally. But in terms of how long they typically will persist, I don't think it's normally this long. So it's a little bizarre. Like it's like something's off, okay? But how off? It's a good question. I can't definitively say like, we haven't seen this in 10,000 years or something. I don't think that's the case, but there's something's off. This solar cycle has been weird in some aspects. So how long to replace that plasma? Well, if it closes up, right, then the sun's always producing energy. It's coming out and going like this it's filtering out from deeper, but usually they kind of just like close up. And Sentient Garden, thanks for your amazing info and dedication. I appreciate it. You have helped raise my consciousness profoundly. Blessings to you. Thank you so much. And a follow-up from Lord Vader. Lord Vader, rise. I answered that earlier as best I could, so I hope you take that answer as your own. Thank you so much. Is this dangerous to us in some way? Only if it provokes maybe a big earthquake. But in terms of a more direct connection, no. But if you're in a city that then gets hit by a big earthquake, there is a risk factor to this. And thank you, C. Martin, for the super thanks. And do I ever do collaboration streams with weather forecast streamers or guests on your show? It's been a while since I've been here. I do plenty of podcasts with other people that I'm interested in. I'll bring them on as a guest. Not too often. This is not just a pure interview channel, but we do that every now and then. But I've never done it with a weather forecast streamer. That's interesting. I'll think about it, but I've never done it specifically with like a weather forecast streamer. In general, I think there's been like 2 weather forecasters that reached out to me after I made a video talking about what I'm about to say, saying I look at space weather, but 99% of meteorologists are ignorant as to space weather, other than, sometimes there's aurora coming, and they use it as opportunity to get engagement. But they have not read the research connecting space weather to Earth weather, which is a shame because it does influence Earth weather. And if you have a big geostorm or coronal ice-free stream about to hit, and there's already a cyclone in the Atlantic, it's probably going to intensify. We've seen that tons of times here on the channel. So we talk about it, but not mainstream meteorologists. No, it's like 1% of meteorologists are even aware that space weather has an effect. And some of them reached out after I talked about that months and months ago. But I can't remember. I can't recall their names off the top of my head. They're not big weather forecasters. Though if you're one of them and you got a ton of followers, drop a comment in the video. I'd be happy to be proven wrong and to send people your way. Thank you, Fingerman, for the super thanks, and Underwater Panther. Thank you for another super thanks. Where does solar science still genuinely surprise you? Or is the human nervous system actually calibrated for the scale of what we can now observe? It's a good question. I think you resonate with what you're paying attention to and observing. So if you spend a lot of time, like for example, I'll use myself as an example. I'm looking at the sun every single day, studying into it, making videos on it, whatever, right? I'm in super deep resonance with the sun as a result. And also, if you look at my astrology chart, tons of sun placements, like crazy stuff in Leo and everything. So, I'm very much in resonance with the sun. I don't get hit into like a non-coherent state when the sun goes into solar flares and such. I'm usually, if it's flaring, I'm out there doing things. So it's really just about how you calibrate yourself to these things and how you enter into resonance with them, I believe. First part of your question, where does solar science still genuinely surprise me? Well, I think the interstellar cosmic stuff is the most interesting to me right now because there's just so much unknown and uncertainty, and it's a big, wide playing field. So a lot of things, for example, even that we've studied quite a bit, have good imagery on, like the Crab Nebula, like these supernova explosions. Those are really interesting to me. And how maybe those affect the climate on Earth. Like there's some research connecting those. We had Max Raymond on the channel talking about that. You can find that old podcast from earlier this year. I think it was like July that we recorded that. So there's a lot of interesting stuff out there. I'm pretty sure I'm not going to be bored at all by the time if I get old and gray, right? we hold on to youth as long as we can. We don't invite it in. And Carlin is asking, have you had any spiritual experiences you believe are directly associated with the solar flares in 2025? Tons of synchronicities and stuff, but nothing like, I'm hanging out and all of a sudden my soul leaves my body. Nothing like that. But tons and tons and tons of synchronicities. And because I'm in such deep resonance with it, I often kind of get like a heads up beforehand, like an intuition, like, I think I should wait like 3-4 hours to make a video, and then a big X flare hits. I'm like, great, now I didn't, make a video too early. So, yeah, nothing like, astral projection or something for me, but tons of dreams. Yeah, some really profound dreams. So yeah, some interesting stuff. New and understanding about the sun and the holes. What is inside the sun? Are we seeing all the way through? What is the black matter inside the sun? Are we seeing all the way through? Yeah, so we are not seeing all the way through. It's showing up dark with this specific view because it's a difference. So, I was out there looking at the sun today. It's still very, very bright. It just shows up dark in comparison to the rest of the sun. Now, sunspots you can actually see, right? If you get, eclipse glasses, you will actually see a sunspot. Sunspot's actually kind of dark. So, and they are actual depressions in the sun. If you view a sunspot, right, a big one, like a big sunspot, right as it rotates onto the exact edge of the sun, you will see the divot on the sun. So it's an actual depression on the sun. The sun's surface is not homogeneous and completely smooth like a perfect ball bearing or something. It's like the Earth. There's divots, there's rises, there's falls, etc. So we're not seeing through the sun with this. What's inside the sun? I mean, we think it's hydrogen and helium, and it probably is, but there are some other ideas out there as to what the sun is or could be and such. We know it has a lot of gravity, and we know it has a certain size. So that's where we start to get density measurements and everything. But have we actually gone to the sun and been like, oh, that's what it is? Now we can look at the spectroscopic data too, because elements and compounds, when they're vibrating, they have emission lines. So we know, like in general, the emission lines for what we see here, but deeper things inside the sun, like these are technically ideas. None of them are technically 100% proven. So keep that in mind. I wouldn't be surprised in 50, 100 years, there's a big shakeup there, but we'll see. Ismail, Ismail, how you doing, bro? The real Ismail Perez, we did a live stream way back a while ago. And he's very active with a lot of very interesting things that he covers on his channel. And exactly, your audience would appreciate my intel. Was it 2 years ago now? That's a while ago. Good to see you here, dude. And yeah, I know a lot of my audience really enjoys and appreciates what you do. So yeah, we'll touch base. I'm sure we'll touch base in some way. Well, we did right now, but glad to see you here and glad to see that you're still doing a lot of good work out there and helping to raise the consciousness field bit by bit. So thanks, dude. And have you ever seen an antipode map of the tectonic plates? It seems like some of the plates come close to butting up against each other, like Antarctica and San Andreas, India, Arabia, Cocos, Nazca. It's bedtime. I mean, we can just look at a general tectonic plate visualization, but yeah, plate tectonics is a new theory and it explains a lot, but I think there's still gaps for sure in that theory that need more explanation. And the theory model probably needs a little bit of recalibration too. We have a lot of data on it. We know that the plates move. We have the GNSS measurements showing the movement of the plates, but it doesn't fully explain everything. So, and we've been seeing a lot of antipodal earthquake activity this year, where we have an earthquake on one location and then nearly the opposite side, another significant earthquake, not just a tiny one, but like magnitude 7 here, magnitude 7 there, the biggest of like the past 3 months, let's say, right? So it's significant. We've been having a lot of that. So there's definitely these, it seems, these vertical stress fields that exist, whereas plate tectonics is typically seen as just horizontal. And then there's convection in the mantle, but there's also these vertical stress dynamics that exist, even cutting through the inner and outer core, which is, we don't have a good explanation for that, but we've been seeing them. So we know that there's something there. You go with observations first, and then you build models and theories off of that, not the other way around. Nowadays, a lot of science is, oh, I just have this idea in my head. Let me spin it up into a model and it looks cool and let me publish it. And now this is what it is. It's like, no, are there even observations that support your fanciful idea? If they're not, then get out, because we need to go by observations first and then create the model that hopefully works to fit all those into one cohesive explanation and understanding. So a lot of super thanks to get through. I expect NASA and other federal departments to be more transparent once this administration implodes. We love our Pele here in Hawaii. Yeah, that's kind of the problem also at NASA, is that, they could just release the 3i Atlas photos when they had them, but instead, they used a shutdown as an excuse to not do it, even though these photos weren't that complicated. Then they did this whole live stream press conference where they're shoving it down your throat. That's a comet. And it's like, guys, it's an interstellar object. I don't think we can definitively say, I don't think that the label of comet even works anymore. It has a lot of comet-like features, but this is something different. We don't know its composition at the end of the day. So yeah, it's just like, I don't know. It's just the European Space Agency at the same time, they got new data. They just published it. They didn't make a big fanfare. They weren't trying to like brainwash you with anything. It says, here's our cool new photo. Check it out. They're doing a good job. But NASA's got some stuff to work on for some. I don't know why, but things also push back because people don't trust them. So it's this whole karma energy thing that I'm not really interested in getting involved within personally. Will you have more of your festivities soon? Yeah, that's coming in really soon. I'm drinking it right now, but we're still waiting on some ingredients to come in. There's been some delays from the supplier. So that should be in stock by the end of the year, but I don't know exactly when. I can't comment exactly when, but hopefully very, very soon. And thank you, Lavinia, for the very generous super thanks from, it's not Swedish, is that? Norway. I'll be in Sweden soon, so I'll be just nearby. And I hope that you are out there getting some views of the aurora. So let me talk about that really quick, because we do have aurora coming up. We may have an updated aurora model for the next 24 hours. Yeah, let me show you what we got here. Here is tonight's aurora forecast. Pretty significant because of the storming that's occurring right now. And then if I turn off behind me, we have tomorrow night's. And I think the night after that will look similar. So the 23rd, they'll probably make it look similar to this one as well, because we're expecting G1 storming from that coronal hole high-speed stream. So make sure you get out there. It's the perfect time to see aurora if you are in the northern hemisphere, because you have all this nighttime, especially in Norway, and we have the conditions for it. We're in solar maximum, the very end, beginning of descending phase. Boom shakalaka. Boom shakalaka. Where I live in 2020, we had a 71-degree Christmas and rain now this year. It's 58 predicted, which is bizarre to me. Yeah, well, some parts of the U.S. have been very, very warm. I'm in San Diego. It's very warm right now. It's been great weather, but not Christmas weather. But it's been, I walked at the beach today, shirt off, feet on the sand, and it was great. But yeah, we're not having a white Christmas here in SD. Central California and much of the state is expecting heavy rain and flood watch Tuesday, Wednesday, Thursday. Thoughts on relation to the coronal hole? Good point. Today's Sunday. Tomorrow's Monday. This is expected to hit us around Monday, Tuesday, that time frame. Probably like late Monday. Probably that zone. In general, geomagnetic storms seem to just intensify whatever weather systems already exist, because they strengthen the global electric circuit. And whether, water and ice crystals have electromagnetic charge, right? A thunderstorm can have 100 million watts of potential energy to it. A rainstorm also can have a lot of energy in it, not as much as a thunderstorm, but still a significant amount. They're highly electrified. When that global electric circuit strengthens and the magnetic field starts to go all wonky, they just intensify. So I would say whatever your weather forecast is saying, plan on it being even more than that. That's the rule that I follow. When I see weather for my area and I know there's a geostorm like a day later that's going to coincide with the rainstorm, and it says like, let's say 1 inch, I'm like, yeah, it's probably going to be 2 inches. And usually it's like, oh yeah, whoa, we were way off. It was way more than 1 inch, because they're not taking this space weather into account. So you just have to kind of do it yourself, but just expect it to be more. How much more is a good question, but expect it to be more. And it's really expected to be big for California the next few days. So, and we are going to call it after, oh my God, these questions keep coming in. But we're going to just finish these up, hopefully. And thoughts on the upcoming Steven Spielberg movie Disclosure Day? I have no thoughts on it. So I can't answer your question really, because I just simply don't have any thoughts on it. I know people are talking about it, like being related to aliens or something, or preemptive programming. But personally, I don't have any thoughts on it. Maybe I will more in the future, but I'm not too interested in the UAP stuff. And we have our newly famous Ray posting a super thanks. Learning your work. Great work, Stefan. Thank you, Ray, for the super thanks. And I will say that I appreciate you doing the live views of 3i Atlas every single morning, or recently also with some of the live streams. If I had a telescope in the land and the property, I would probably be doing that, maybe not every single day, but quite often myself. So I think that's great. And this is also a good opportunity to educate a lot of people as to some of the basics of astronomy. So if you're looking at the comet, describing, what we're seeing with the coma and the jet or the tails, and, I'm zoomed in here, so we're gonna have more noise, and we have atmospheric distortions and all this stuff. So you've been getting a lot of viewership recently, which is great. So it's a good opportunity to educate people as to these things so we can all be a bit more knowledgeable and empowered from that. So good to see you here, Ray, and keep up the good work in terms of capturing 3i Atlas for those who are interested. River's Edge, thank you for all your work and charity. Thank you for the super thanks. And Pocket Kev, happy solstice, Stefan. What are your 2 cents on the growing Earth model to explain plate tectonics? I think it's interesting. I'm not someone to immediately just discount it because there's this idea of like expanding Earth, and I wouldn't call it a theory. I'd call it a hypothesis, the expanding Earth hypothesis. But you know, there's something to that. I can't immediately dismiss it. I think there's something to it. But there's so many things to research. Right now, my focus is really interstellar. But at some point soon, I'll get back to doing some more deep Earth research. And I always am, but like a really dedicated whack at that. And then I'll have a better sense of kind of what the deal is. But we do see this differentiation process that occurs. So if you have, let's say, this is just a speculative thought experiment, okay? So we're saying that right from the start. But if you have this kind of transmutation that's occurring due to chemical processes in the Earth that is transmuting denser elements, let's say, and compounds and minerals to less dense ones, right? Well, that would necessarily cause the Earth to expand over time, if that is the case. Don't know if that's the case or not, but maybe there is some basis for that, that when you have this flow of energy and it hits magnesium, let's say, and all of a sudden MgO, like magnesium oxide, becomes magnesium bioxide or whatever, I'm just making something up. It is more, its lattice structure is more expanded and lower density, right? We know that rocks have different densities. Felsic rock, mafic rock, basaltic rocks are dense, and granite is less dense. It's stronger though. And we see this natural production of rocks like granite from certain types of volcanoes. So we know that there's this, we know this exists actually. So that could explain, take enough of that happening at a global scale, that could explain the Earth actually getting slowly bigger over time. And that could help explain plate tectonics to some degree. So again, there's something to it, but how much I can't say. And a lot of it is just kind of a speculation at this point. So that is literally 2 cents. And our coronal hole is seen as opening and is nothing to be afraid of. It's a sign that we are having the greatest heart chakra opening ever. Time to radiate unconditional love. What are your thoughts? I love it. Whether that's true or not, I don't care. It's a good message. And I think that is the truth. So we need to be spreading more light and positivity. Not ignorantly, right? We need to do our best to be accurate and truthful. But also, after that's been done, to be just good people. So I love it. Keep it up. I love all that stuff. It's just a good mindset to have. There's so much negativity out there nowadays that some of these people are like, oh, we don't like the spiritual people or the hippies. It's like, are they hurting you? All they're saying is like peace and love. So what's the problem? They may be talking about some wacko thing that, it's like, we don't know. Some like, oh, the Space Force is coming in and it's going to bring light into our planet. I don't know, okay? But if the end message is good and it's peace and love, hey, I'm all aboard, okay? Put me on the spaceship. So I'm for it. Have you ever had an Akashic record reading? If so, what starseed are you? No, I've never had one like specifically. I have an idea, but I'm not exactly sure. So I'll leave it up to you guys to kind of maybe figure out or think about. And Margarita Diaz, last super thanks question that we'll do in this Q&A. With so many solar ejections, will the sun lose magnetism and cause a planet's disalignment into the solar system to collapse? No, the sun's a very big system. So, I mean, something beyond our comprehension would have to happen for that to occur. But we're not held in place by magnetism. At the planetary scale, it's gravity that holds us in place. So Electromagnetism is the powerful force doing a lot of other things, but it's gravity that's causing us to all move around the sun. So if the sun, like, let's do a thought experiment to kind of flesh out your question a bit more. Let's say we enter into a grand solar minimum. Okay, so we're not having increased magnetism on the sun because you get stronger magnetic fields from the sun during solar maximum. During solar minimum, let's say a grand solar minimum, like 50 years long, the magnetic field of the sun is weaker. The heliosphere shrinks, but we haven't seen the planets collapse because of that before. And we have these grand solar minimums every few hundred years. So it seems, and sometimes they really cluster together. So nothing to worry about there. Thankfully, could 3I Atlas possibly be from a supernova? Maybe more to come. As far as we know, no, but possible. I mean, supernovas are big events, and if something got flung out, you know, it's very fast. But I would think it would have to be like at the edge of the effect, because a supernova would just obliterate whatever it hits. It just totally vaporize it. So it'd be at like the far edge of a shock wave, and then a chunk gets launched from a planet or something like that. So yeah, we are going to finish off with just some singing bowls, a quick cosmic connection meditation. So get comfy, folks. I'm going to get the singing bowl out. This is not going to be a long one, but we will do a little something because it'll be nice. And yeah, just find a comfortable position and we shall get started. See you later, Drew. He's not interested in meditating. I'm here for science and I'm out with the spirituality. And that's fine. But this is science. The science of frequency, vibration, resonance. Nikola Tesla, he understood. He knew. Newton, Isaac Newton, Einstein, all of them were very, very aware of this. Yes, join us, Drew. I think it may be a bit loud, so let me turn it down a bit. Okay. Namaste, namaste. Wishing all of you the absolute best. Happy winter solstice, December 21st, 2025. We shared this moment together. For everyone watching on repeat, thank you for joining in as well. Hope you had a great day, a great year. We begin a new year very soon. The energies are very strong and transformative right now. So just be mindful of that. Rest when needed. We don't always need to go, go, go. So that's one of the problems of society right now. Maybe think about reducing the coffee consumption. It helps for sure. Just let the nervous system relax, because in that place of relaxation is where creativity flourishes. So with that, wish you all well, have a great day, and I'll see you all in the next video. Namaste.